Hello everyone. So this is my first ever video about modular synthesis and VCV Rack and that sort of thing. It's a new thing I've been getting into the last few weeks. I spent about a month playing around in VCV Rack, trying to learn as much as I could and see if this was something I really wanted to get into in real life, and decided, yeah, I wanted to spend a little less time in front of my computer when I wasn't working and have a physical device to play around with. So I picked up this little NiftyCASE. I picked up the whole bundle from Create Audio, and I just figured I'd do this video introduction to show what I've done with it so far and how I'm using it with VCV Rack, because I didn't really find a whole lot of information about how I would be able to do the integration. So I'll talk about that and this little board that I soldered up here. I don't think I really need to do like a whole introduction of everything about the NiftyCASE and the bundle and chips and cells. There's some really great informative videos out there already. What I do want to talk about firstly is kind of the biggest, kind of weirdest letdown of sorts that I didn't realize was going to be the case when I bought the NiftyCASE, and that's that the outputs, I knew that they were mixed down to a single line out, and it's mono, and so there wouldn't really be, you can't just like plug a set of headphones in there and listen. What I didn't anticipate was how hot the levels were going to be. I knew I'd read that Eurorack levels were higher than headphone levels, but having never messed with a real life Eurorack, I didn't realize it was going to be so hot that it would cause literally everything I own that I plugged it into to clip. I have this little Zoom microphone slash interface, the H1N, that I plugged in and used that as a USB audio interface. It can't handle it. None of my headphones can handle it. So the first night of having this thing, I was pretty bummed because it sounds like trash. All of the sounds you would get from here were just horribly distorted and clipped, and it was a bit of a bummer. What I did is I had some parts already from some other DIY projects that I'd done on the side, is I just wired up two mono inputs running through some 100K trim pots that then go to a stereo output, so each channel goes going left or right. So it's still not ideal to like plug your headphones in there because you're just going to hear one from each side. But what this does allow me to do is attenuate each channel. I can also balance them a little bit, because that's the other thing that I forgot to mention, is that oscillator 2 on chips is a lot louder than oscillator 1. I'm going to assume that it's because of the filter circuit on oscillator 1 that probably does some attenuation. But what that results in is if you plug them both directly into here and then try to just attenuate on the output, you really end up only hearing oscillator 2. There's such a dramatic difference between the two channels, you really don't get anything useful out of that. So this way I was able to basically have them both going at the same time, listen to it and adjust it so that I get a pretty close to even output from both, and also attenuate both of them down to not be clipping my audio interface. So yeah, it's messy because I don't intend this to be a permanent solution. I was just really frustrated at like 10 p.m. last night, so I just whipped out what I had and threw it together and it's actually worked out pretty well. So maybe I will ultimately make a much more permanent, nicer version of this. But I think once I get some other modules, like some actual VCAs, I might be able to make better use and not need this. But for now, that's like $5 in parts or something. Then the other part that I'm doing with my NiftyCASE here is I have the USB plugged in from my laptop, and then like I said, this audio, the two channels are on a stereo cable running to my H1N USB audio interface. So basically I get left and right, or two separate channels. and I've connected those in VCV Rack like this. I have an audio here for the interface. I select the H series track audio, and I have left and right. I run those through some mutes here so I can just easily turn them on and off without having to mess with anything else. Right now I have those fed directly to a mixer and down into an output, which I have just connected to the built-in audio output of my Mac here. So for example, if I unmute, we should start to hear. Yeah, here we go. So that's chips 1. You can hear it's a little noisy. I think some of that's probably coming from here. I'm not sure. I know the chips themselves are noisy. But I'm not gonna totally write off that my poorly soldered DIY guy here isn't causing some problems. So I can turn that one off, and then we can go here. This is chips 2. We got that one. Has the pulse width. We can adjust the different wave shapes. You know, we've seen all this before if you've read anything about this. And then I'll flip them both on, and we've got 2 sounds that interact, and you know, we can actually make some cool sounding stuff with this versus the overdriven sounds and tones that we're coming for. So yeah, I don't really have that much of a musical background, you know. I mean, I guess I did play like bass and drums for a while as a kid, but as an adult, I don't really have much of a relationship with music. As an electrical engineer by training and a software guy in my day-to-day, I do find this stuff very interesting. Specifically, when I started reading about generative patches and things like the Krell patch, I just became really engrossed by it. So I just, you know, that's kind of where I see this going for me, is, you know, learning more about generative audio synthesis, and see what kind of cool things I can make with this. And so to that end, there is one really awesome thing that I learned about chips in my experimentation last night. Because if you know much about the Krell patch, which I can link to some videos where people can do a far better job explaining it than me, because I've really only just started learning about it, and I've patched it up a few times in various ways in VCV Rack. But there's a few key things that you need. One is some sort of envelope generator that has voltage controlled attack, voltage controlled decay, an end of cycle trigger. So all of that in your envelope generator. And then you need some VCAs, obviously, because like they say, you can never have too many. You use those to control various things in the flow. Then you need a single oscillator to get one sound source going. So we've got 2, so that's cool. You need a way to modulate those attack and decay times on your envelope generator. And so you can do that with LFOs. I've done it a couple different ways, just with random value generators in VCV Rack, just LFOs. I've done sort of where you use the random value to modulate the LFOs, you get even more randomness, that kind of thing. So basically you need 2 modulation sources, one for attack, one for decay. And then you also need your random audio source, typically something like random voltage generator, so noise plus sample and hold. And so the interesting thing that I learned about chips is that because it has these LFOs built in, and those LFOs have this strange noise waveform, you can actually generate a sample and hold on chips from random noise and get a controllable random voltage to run into your volts per octave pitch control of the oscillator. So I'm going to show that right now. So here, this is our oscillator number 2. I'm going to switch over. This is what the noise sounds like. You can tell it's just pretty wild. But if we leave this at sine and we take that same noise from this LFO, I'll take the slower of the two, and I plug that into my voltage control. Well, now oscillator 2 is cycling through random voltages from this LFO. And if I change the rate, I can slow it down, speed it up. I can tune it here if I want to tweak that. Adjusting this gives us some different sounds. I'm just going to leave it on sine and full width just because that's the most pleasant. I can use depth to kind of adjust the range so it won't go as high. So we'll get a smaller spread. And this is honestly, like, when I discovered this, I was like, wow, this is amazing. I basically got, because I was looking at sample and holds and noise or something like a Turing machine. And while obviously this isn't amazing, I can get started doing Krell patches and other generative things just with this, because look, right now we sort of have a generative patch, right? And especially connecting into VCV Rack, we can do some pretty cool things. So I'm going to mute this. And let's just go through building the whole Krell patch. How about that? A very simple one. So like I said, you need an envelope generator. So I'm going to use the Rampage from Bafico. This is really great module that has everything we need, because we can control the rise and fall via control voltage, and we get an end of cycle signal, and then we get the output of our envelope that is being randomly cycling. And then we need a couple of LFOs. I'll just use the simplest option. So we need a couple of LFOs, one for the rise and one for the fall. So I'm going to use my Oct module, which is kind of my favorite LFO to use when I don't need a whole lot of control and I just want things that are kind of somewhat linked to each other. So I'm just going to choose 2 different rates here in the middle, connect those to rise and fall, put the Rampage in cycle mode so it'll constantly repeat. And if we fire the trigger right now, so now we see these red rise, fall, our outputs. Should see an end of cycle. Oh, maybe there's not an LED for end of cycle. So we can take that envelope and we will push that out to the control voltage on our, I think I'm using the second channel, right? Yeah, so on our mixer. And so let's just start there. And yeah, you can hear that envelope cycling through as we change here. But see, now our notes are not cycling at the same rate as the envelope. I'm going to slow that envelope way down so it's less distorted here. But our notes, like I said, from the random number generator are not cycling at the same rate as our envelope is triggering the VCA. But we can fix that. So what I have here is the CV to MIDI. I have that connected to create audio NiftyCASE on channel 1. We have control voltage gate, modulator, and clock. If you want to use both of these, you need gate to MIDI. You could put that in here and then you can use the gates, but I'm just going to be using the clock and maybe a control voltage right now. And so on the NiftyCASE connections, these things are labeled incorrectly. So if we take our end of cycle signal and we put that into start, that start is actually the clock on NiftyCASE. And there was a video, I can't remember the name, but I'll link to it here, where he goes through what each of these are linked to, and without his help, I don't think I would have been able to do this last night. So yeah, let's start with that. Actually, I'm gonna change some things here. So I'm gonna take this clock, I'm gonna put it here in the reset. And now you can see every time we get an end of cycle trigger, we get a gate here, and that restarts this. So we basically now have our LFO being triggered by the end of cycle of the rampage. So every time a cycle ends, we get a new random voltage from the LFO, and that sets us at a new value on the oscillator. So our pitch changes. And then at the same time, our envelope created by the rampage is controlling the envelope of the VCA. So we get a note, we get a new pitch, and we get enveloped volume all at the same time. So we're all kind of in the same timing. And then these two LFOs controlling the rise and fall time mean that the window is kind of ever changing and fluctuating. You can see our notes are different lengths. They have varying attack and varying decay. And we can adjust that by these offsets to have some effect here. We can speed up some parts. We can do a bigger thing to make it all faster all the way around. We could switch to different pitches here or different rates here. I think what I want to do is make it so is introduce some feedback into this, which that's kind of the big thing about a generative patch is like, okay, where can we make it so that the things that we're creating affect each other? And so a really easy way to do that would be to take this output, our envelope, and let's feed that back into our oct. Our envelope that we're creating is affecting the rates in those LFOs, which is then affecting the envelope. So we have a circular dependency there, which makes for a lot more cool, awesome randomness. Now, this is not a great sounding Krell patch. I'm not sure it's anything to be super proud of, but it is a pretty nifty proof of the cool stuff we can do right out of the box with a NiftyCASE. 2 modules and a little bit of connecting up our audio and MIDI inputs, plus my little solder job here, and hopefully that'll go away. I do have a few other modules already on the way because I knew that, you know, just these two wasn't really gonna be an awesome starting point. And of course, you know, it wouldn't be modular Euro Rack if we weren't just like constantly craving new modules. But I am gonna try to keep new modules to a minimum because I don't have a lot of space here, and I don't want to really grow beyond this rack too early on. And I want to really try to master the cool things that I can do with just a couple modules at a time. But what I have coming is some VCAs, and I got an envelope generator that I think will do a very similar job to the Rampage here. I have one of these aux on the way because I found myself using it all of the time, and I was like, I think I'm just gonna need that in real life. I think that's about it for right now. So we'll see where we can go from there, plus this connection into VCV Rack, kind of keep growing, and you know, we'll just go from there. Well, thanks a lot. I hope this was informative in some ways. If so, and you want to kind of follow my journey, just like and subscribe. Thanks a lot.